Hey guys, in this video we would understand how to evaluate logarithms. Now logarithms can be evaluated in two ways. Now first let's understand what do you mean by evaluating. Evaluating means finding the value of. So if we get the value that is a numerical value, that means we have evaluated the logarithms. Evaluating procedure is basically two types. One is we can use calculators and one is we cannot use calculators. So one way of evaluating is without calculators and another way you can evaluate is using the calculator. So with or without calculator, there is two ways to do it. Let's take up without calculator way. So the first way of without calculator way is to convert logs to exponential form and then solve it. Example of this would be if we have to evaluate log to the base 2 of 8. Then how do we do that is we first change it to exponential form. Base is 2, so we'll keep 2 as the base. To the power of x is equal to 8 because we interchange this and this that we learned in the first lesson. Next is we try to make the bases common. So this 8 can be written as 2 to the power of 3. If we have the same bases, we can cancel them out. So we are left with x equal to 3 as the final answer. Therefore, we can say log to the base of 2 of 8 is equal to 3. And that's the answer. Another way we can do is we can use laws of logarithms that we have learned in the previous video, that is lesson number 3. So how do we do this? If you want to solve the same question, but we would be using laws in this case. Now we're looking to evaluate log to the base 2 of 8. What we have to do is just change this number to the same base as the base of the log. So 8 can be written as 2 to the power of 3. We can only solve without calculators if we can make the bases common. So the base of this and the base of the value should be same. Log to the base 2 of 2 to the power of 3. Now this resembles the law of logarithm that we have covered up in the previous lesson. Log to the base of b m to the power n. So in this case we would take n out. N would be multiplied with log to the base b of m, and we do the same thing here. Log to the base 2 of 2, this 3 is taken out and multiplied with this whole thing. Then there is another law, and the law says that if you have log to the base b of b, so if this was not m, if this was b, or if this number and this number were same, that is what we see here, then this can be written as 1. If we apply the same rule here, log to the base 2 of 2 is 1. 3 times 1 gives us a 3. Therefore, the final answer we can say is log to the base 2 of 8 is 3. So this is how we evaluate logs without using calculator. First method is we can change logs to exponent form. So we can rewrite it in exponential function form. Base stays the same. We just have to interchange these two. This is dependent variable, this becomes independent, and this becomes dependent, so this goes outside, and we just make the bases common and then we simplify it. The reason it's under without calculator category is because we can make the bases common. If we would not have been able to make these bases common, or if 8 would not have been able to be written as 2 to the power of 3, then we would not have been able to do it using without calculator method. Next is we can do it using laws. So we applied these two laws in this particular case. But before applying the laws, we need to make sure again here is that we have to change it to the same base as this. So 8 can be written as 2 to the power of 3. Then we apply the laws. Here comes the power law or the power rule. So 3 comes outside multiplied by log to the base 2 of 2. Next is the same base rule. So if the bases are same and this number is same, then we can just write it as 1, and the final answer we got is log to the base 2 of 8 is 3. Next we're going to solve is with calculator. With calculator we have these two ways. One is we change logs to exponential function form. Example for this is if we are supposed to evaluate log to the base 2 of 10, we would be only using calculators if we see that the value that we have to evaluate for cannot be changed to the same base as the base of the log. So 10 cannot be written as 2 to the power of something. Therefore, what are we going to do is we're going to put this equal to x. So base is 2 to the power of x is equal to 10. Now we want to use the calculator to solve this, so we would do it with trial and error. And what is trial and error way is that you would think which power of 2 can make you go up to 10 or close to 10 basically. Like here 2 to the power of 3 will give you the answer 8. Now what power of 2 will give you the answer 10. That's what we're looking for, and we would get a decimal number, and we would see that 2 to the power of 3.3 maybe gives us a value that is close to 10. It's 9 point something. That's why it's called the trial and error method, because we do not get exact answer for this. So finally, bases are common. We can write down x as 3.3. Next we solve is using laws. The same question with calculator and laws. How do we solve it? If we have log to the base 2 of 10 and we have to apply the laws in this case, then we apply a law called making the logs as the log base 10. So we can use this law. Log to the base of b of a can be written as log a over log b. So we would write this as log 10 over log 2, and then we just have to put log 10 divided by log 2 on the calculator. The answer that we get is the final answer, and that is, and we get 1 divided by 0.3, and that gives us a value of 3.33. So these are basically the 4 methods of evaluating logarithms. If we can make the bases common, like we had been able to make it here, then we choose to do it without calculators. But if we cannot make the bases common, then we choose it doing with calculator. Let's do some examples for the sake of practice. So if we have to evaluate log to the base 6 of 1, now we see that 1 can be written as a base of 6 because 1 is nothing but any number raised to the power of 0. So we can write on 6 raised to the power of 0 because we want the base to be 6. So you write on log to the base 6 of 6 to the power of 0. And then we can apply the law. And the law is the power law. So we can bring this 0 out. 0 multiplied by log to the base 6 of 6. When we have same base and number here, we can write it as 1. So 0 multiplied by 1 is 0. Now let's say if you're supposed to find out log to the base of 4 of 1 over 64. How do we solve this? We would first think, can we change 64 to the base of 4? So we always try to go without using calculator method first. And we know that 4 to the power of 3 is nothing but 64. So how are we going to write this down is, we would write it down as 1 over 4 to the power of 3. Now we would see that if I put in 1 as the power of 3, that would also give me 1 back again. So I can write this down as log to the base of 4, 1 over 4 whole to the power of 3. And why do I need to do this is because I want this base to be 4, not 1 over 4. Now if I flip the base, this is exponent rule from the previous grades. You're supposed to know it, that when the base is reciprocated, the power becomes negative. So if it is 1 over 4 to the power of 3 and I write it down as 4, power becomes minus 3. So I'm gonna reciprocate the base and it becomes 4 to the power of negative 3. Once I get that, now I'm going to apply the power law of logarithm, and when I apply the power law, this is going to come out. So I would get negative 3 log to the base 4 of 4, and we finally get log to the base 4 of 4 is 1. So the final answer is negative 3. So always remember, we try to change the given number to the exponential form in such a way the base of the log and the base of the given number should be the same. And if you're not able to do that, then we would have to use the calculator. Let's take up another question. If we have log to the base of 7 and this is root 7, we can write down this root 7 as 7 to the power of 1 over 2. Again, we can apply the power law. So 1 over 2 or half can come out, and we are left with half times log to the base 7 of 7. This and this is same, means this can be written as 1. So half multiplied by 1 is half is the final. If we have to solve this is very easy. Power is x. We're going to bring it out. So we would be left with x times log to the base 5 of 5. Log 5 of 5 is nothing but 1. So we would be left with x is the final answer. Let's say we have to solve this log to the base 3 of 112. Now we know it's 112 to change to base 3 is not possible because we won't be able to get 112 equal to 3 to the power of something. So what are we going to do is we're going to use calculator for this and the laws. So we would just first change it to the base 10. So that would be log of 112 divided by log of 3. Then we put this on the calculator. Log of 112 gives us 2.05. Log of 3 gives us 0.477. And when we divide this, we would get 4.2976, or we can just simply say 4.3 is the final answer. Let's take up the last problem. 6 to the power of log to the base of 6 of x. So this is an exponential function problem where the power is written in terms of log. In order to solve this question, we would first write this whole thing in terms of another variable. So 6 to the power of log to the base 6 of x is y. Now to solve this, we would change it to logarithmic function form, because this is 6 to the power of something equal to y. Basically, this is exponential function form. If I want to write it as a logarithmic function form, I'm going to write it down as log to the base of 6, because base is 6. And I'm going to interchange this and this. So log to the base 6 of y would be equal to log to the base 6 of x. Now we can see here this is exactly the same, log to the base 6 of y, log to the base 6 of x. As with the same bases, when we write on 2 to the power of 3 and 2 to the power of x, we can cancel the same bases and we can make the powers equal. Similarly, we can also cancel the logs if they are exactly same on the two sides of the equal to. So log to the base 6 and log to the base 6 we can cancel out, and we can finally write down that y is equal to x. So therefore, let's go over this once again. 6 to the power of log to the base 6 of x. We rewrite the whole thing, this equal to y. That's what we did here. And then we changed it to logarithmic form. Logarithmic form is log to the base of 6, because the base is 6 here, of y is equal to this whole thing. And then we see that log to the base 6, log to the base 6 is exactly same terms on each side of the equal to sign. We cancel them out. We are left with y is equal to x. And our goal was to find out what is x, and x is nothing but equal to y.